So why is it that color space and LUTs and OCIO and ACEs, why is it that all of this just seems so darn confusing? Well, the short answer is that there's so many different things out there in the world that interpret or express color. And this is really the key thing to focus on here. Whenever you look at something like a smartphone or a camera or a computer monitor, it's going to be interpreting the color that goes into it, or it's going to be expressing color that it projects towards your eyes. So for right now, I want you to think about the input color space as the thing that interprets color, whereas the output color space is the way that something expresses color. So anytime you see input color space, think of this. Anytime you see output color space, think of it as, again, the way something expresses color. Now, to play this out, and to understand this better, I want to bring forth just a very basic production scenario. Let's say that we have some CG elements on the left with Houdini Redshift, and we have some real-life footage that's being captured by Red. So, in the case of Houdini Redshift EXR, assuming that we don't have any ACEs or OCIO going on, what's happening is that the input color space, the way that Houdini interprets color, by default is going to be sRGB. That again says that if we take a look at our CIE diagram, it's going to be this red triangle right there. That's the way that Houdini understands color. So that means that if we have lights in our scene, say that that's a beautiful looking light, and we have textures and we have colors that we pick on our shaders, those are all existing within this sRGB triangle. Okay, so that's the case there. Those ingredients get sent to Redshift, as an example. And Redshift is basically just the engine that thinks about the ingredients that you just fed it. So it's thinking about those colors that you just gave it. And it's going to then give us an EXR file, which can then become the final result. So again, thinking about input color space, it starts with the application, Houdini, because that's what's responsible for feeding Redshift the information which allows us to have those greater variations in color. It affects our lights, it affects our textures, and that's how we get the better looking image. Now, when it comes to the output color space, this is where things get a little bit interesting with the EXR. If let's say we wanted to preview this EXR on a computer monitor, we would want to say that the output color space of that EXR should match wherever it's going. So if you go, let's say, on your computer monitor and you set this color space to sRGB, then that means in order to view this EXR file properly, this needs to be sRGB. Now, in production, that's not what you do. In production, what you want to do is you want to send this to a compositing application. Let's say that this is Fusion, linearly. That means don't change the information on the EXR to account for a computer monitor or a movie projector. Don't change the information, just keep it the way it is. That's what linear is going to do for you. And then once we're in Fusion, that's when we take this over to do all of our color correction. And then from Fusion, we could say that this is, let's say, sRGB, and we can pick a different profile for the projector or for whatever medium we're trying to go to eventually. So that is basically a small example of input and output color space. The outputs, the way that something expresses color, is often going to be on the file, okay? Or on the final deliverables that are exported from, let's say, Fusion. Okay, so let's think about our friend Red real quick. With Red, we have a camera sensor. And light hits that camera sensor, and this will give us the raw signal, okay? Now, the problem with the raw signal and the problem with all video cameras is that this does not interpret light nearly as well as our eyes do. And so because of that, camera manufacturers, all camera manufacturers, put their own output color space on this raw signal. They do that because they want the image to look closer to what our eyes see, or they want it to look more appealing than what the raw data comes up with. So we can say that the output color space of this raw signal ends up being encoded into the file formats. So in other words, this goes through an output color transformation. And notice how I said transform. We are transforming the raw signal into a different output color space. And we're doing that for aesthetic reasons, and we can also do that for saving disk space as well. So this actual file right here, because it uses lots of different frames and, it could be shooting 60 frames per second, we need to do things to compress, to reduce that file size. And so when we encode the raw signal, when we're applying this color transformation, it's not only changing the visual color, the way that something expresses color, it's also doing that to reduce the file size. And so in this very simple example, we have an output color space happening between the raw signal and what gets encoded on this file. And so if we take a look at the color format now on this R3D file, we could say that the output color space, just for simplicity's sake, let's say that this is R3D. This is not what the color space is actually called, but let's just say that this is Red's color space that it likes to use, okay? So that, let's say, goes to Fusion. We have an sRGB signal going here to Fusion as well, and somehow we need to make all these different ingredients work well for a computer monitor, a projector, or a smartphone, all these different things. And so, as you can imagine, if we had, let's say, 5 different cameras used on a shoot, and we have some renders coming in as sRGB from this other studio, they came in with ACES, this basically creates a situation where all the stuff that gets given to a compositor ends up showing up in these different color spaces. And, as you can imagine, that has turned into quite the mess for compositors in the past. And this has really been the bane of many studios' existences, because they have to manage the stuff that's coming into the compositing application as well as where it's going to maintain consistent colors from one thing to the next. This is the main reason why ACES was created in the first place. Because what we can do with ACES is we can take all of these input color spaces, we can turn that into ACES, and then we can output ACES into any color space we want to fit whatever medium we're trying to go to. So ACES is basically just a way of converting color spaces, right? We take this sRGB, this whatever color transform, and we convert that into this wide gamut. We do our color corrections within the wide gamut for everything, and then we have the ability to re-export this out into whatever medium we're trying to do. So that is why ACES exists in the first place. In CG, the reason why we would use ACES up here is because we want to take advantage of this wide color gamut right off the bat so that we can send Redshift better information. So in other words, the reason why you use ACES CG up here in the CG space is so that we can take advantage of more colors and tonality and stuff. And the reason why we use ACES over here on the compositing side is so that we can adjust colors better, as well as turn all of these other formats into ACES and then convert them to whatever medium we're trying to go to. So this becomes the in-between format for doing whatever it is you want to do no matter where something is coming from or no matter where something is going. So one more time, for the CG artist, let's reiterate what we want to do. We've taken Houdini, we've changed its input color space to be aces, so that now all of our colors exist within this big triangle. That converts our lights to the wider gamuts. If we convert our textures, those are also going to be in the wide gamuts. That gets fed to Redshift. That becomes our EXR file. And if we're working within a production pipeline, we want to take that EXR file and linearly set that over to Fusion. So if you give a compositor an EXR file that's linear, that's what you want. Again, by saying linear, you're saying, hey, don't try to take this information and make it play nicely with the computer screen or a projector or anything like that. Just take the information as is. Now, if let's say you're just a solo CG artist, you're trying to put together a demo reel, and you render something in Redshift and everything looks all foggy and weird, well, that's probably because you're looking at a linear file that hasn't had a outputs color space transformation happen for your monitor. So let's say that your monitor here is Rec 709, right? And you render something out linearly, it's going to look really pale and weird because you haven't told that EXR to output its color space as Rec 709, which is what your monitor is set to. So, just watch out for that. If you've ever used ACES with Redshift or with any other render application, most of the time it's going to give you a linear file because they're assuming that you're working within production and you want to send this off to a compositing department. And then, of course, your compositors ultimately make that final transformation, that final output color space to Rec 709 or whatever the medium happens to be. So there you go. Hopefully that clears up some of this information. In the next video, let's move on to something else.